Hello guys, today we'll take up the very interesting topic of the science of explosives. Well, most of us have wondered at one point or another what makes certain substances explosive in nature, and through this session we are going to discover precisely that. The first important thing to note is that most chemical explosives in the world currently in use involve one or another type of redox reaction. And the basic principle involved in such compounds is actually very simple. The principle is create a compound create a compound in which there is an imbalance in terms of oxidation numbers in terms of oxidation numbers and this imbalance is usually brought about in this fashion. We create a compound in which there is a highly electronegative element present in high oxidation number, and at the same time there is an electropositive element present in low oxidation number, and this precisely creates an imbalance because highly electronegative elements are actually more stable in low oxidation numbers, while electropositive elements do not mind being in high oxidation numbers. And this imbalance makes such compounds explosive in nature. So let us take some examples. The first example in this list is the famous compound nitroglycerine, which is actually an ester of glycerine and nitric acid and has the following structural formula. Now let us write the oxidation number of various elements present in this compound. This carbon is present in -1 oxidation number, nitrogen in +5, this carbon in 0, once again nitrogen in +5, this carbon in -1, this nitrogen in +5, and hydrogen and oxygen atoms have their usual oxidation numbers, which is +1 and -2 for each hydrogen and oxygen atom. So clearly in this compound we observe that there is an imbalance in terms of oxidation numbers of carbon and nitrogen atoms. Carbon, which is of lower electronegativity, that is 2.5, is present in a low oxidation number, -1 or 0, while at the same time nitrogen, which is more electronegative, is present in a very high oxidation number, in fact the highest possible for nitrogen, and +5. And therefore there is an imbalance, there is a huge imbalance. Nitrogen ought to be in a low oxidation number and carbon at the same time should have been present in a high oxidation number. Therefore this compound, when subjected to shock or heat, it explodes and converts into CO2, nitrogen, water, and along with some oxygen also comes out. And over here, if we look at the products, now we'll see that this particular imbalance in terms of oxidation numbers has been completely removed, with carbon now present in its usual oxidation number of +4, and nitrogen has reduced its oxidation number to 0. So nitrogen from +5 to 0, so it has come to its more usual oxidation number, and carbon from -1 or 0, it has moved on to +4, and therefore this imbalance has been removed. So this is the first example. Now let us take another example. So the second example is another very famous explosive substance, ammonium nitrate. Now if you look at this compound, you will observe that one of the nitrogens in this compound is present in a very low oxidation number, -3, and at the same time the second nitrogen atom is present in a very high oxidation number, which is +5, and this again is creating an imbalance because each nitrogen atom has the same electronegativity, and yet one nitrogen is present in a very low oxidation number and the other nitrogen is present in a high oxidation number, and therefore when this compound is subjected to heat or shock, so this also decomposes to nitrous oxide and water, and here you will observe that each nitrogen is present in a +1 oxidation number, and this has removed the imbalance. So now, summarizing the whole concept of explosives, we can say that explosives basically work so as to remove the imbalance. So imbalance is removed and a balance is brought about in terms of oxidation numbers. So I hope through this session we have lifted the mystery from the science of explosives, and this is one of the great applications of redox reactions which we have covered today. So see you guys once again.